Hello and welcome to lesson number 5 in Unit 2A, Quadratic Functions, Forms and Transformations in our grade 11 University College math class. This is sketching graphs using transformations. So now we have all of the transformations sort of under control. We've learned how the transformations made to f at x equals x squared can be mapped onto the roles of a, h, and k when we see a quadratic in vertex form. At the top of the note here we have a nice little summary, so let's just have a quick look at that. First thing we notice is that when we have our quadratic in this form, we have the a value just parked out front, and that tells us two things. It tells us first whether there's a reflection across the x-axis, and it also tells us whether there's a vertical expansion or compression, or neither. The second transformation that we look at is the h value, which is housed inside the brackets. Just remember that that h value is the opposite of how it appears. So if it looks negative, it's actually positive. And those correspond to horizontal translations either left or right. Positive h values that look negative will be transitions to the right. Negative h values that look positive will be transitions to the left. And lastly, we have the k value, which is vertical translations up and down, and we take that at face value. So a positive k value goes up, a negative k value translates down. So the first thing we're going to do in this lesson is just do a quick little exercise on what the order of the transformations is. And we're going to graph y equals negative x squared plus 3 in two different orders. The first thing we're going to do is we are going to reflect, let's get a highlighter on here. First thing we're going to do is reflect across the x-axis and then translate 3 units up. So reflect first and then translate up 3 units. So let's start with that one. So we have our parent function again. Our parent function would be going through the vertex, out 1, up 1 from the vertex, out 2, up 4, out 3, up 9. And that is our parent function. So that one's not the one we're actually sketching. That's just the parent. So what we're going to do with the first one is, first thing we're going to do is reflect it. So, you know what, I shouldn't have done that in green. Let's make this one like dark blue. There we go. Okay, so let's make this reflection now in green. So we're going to reflect it first, so that will be from the vertex out 1, down 1, out 2, down 4, and out 3, down 9. There we go. So that is our reflection first, and then we're going to take this whole shape and we are going to shift it up 3 units. So let me see if I can catch this whole shape. And we are going to shift it up 3 units. So that'll go up to 1, 2, 3. It's pretty close. So that's about where we want it. Let me get that vertex on there since I didn't sketch it. There we go. So that's our first one. Reflection first and then up. Our second one we are going to do is going to be first translated 3. Oh, come on, highlighter. First we want to go 3 units up. 3 units up first, and then reflect across the x-axis. So let's sketch what that thing would look like. So first thing we're going to do is sketch it 3 up. So there would be our vertex. From that vertex, out 1, up 1, out 2, up 4. 1, 2, 3. Oops. 1, 2, 3, 4. And 9's not going to really fit on there very nicely. So we'll just sort of sketch this one through as it is like this. So there we go. That is now shifted up first and now reflected. Now recall, we're reflecting this across the x-axis. So when we actually reflect it, the vertex will be down here at -3, and then it's going to be opening down, out 1, down 1, out 2, down 4, 1, 2, 3, 4, and again we'll skip 9. So this is it. So those are our two different orders for doing this. So which one is correct? Well, I guess the question is first, what do you notice? Obviously, they're different. They are different. Which means that depending on the order, you're going to end up with a different result. And we sort of have to agree on an order that will result in us ending up with the same graph all the time. So the order that we're going to follow is bed mass, really. So what we're going to tackle here when we're making these sketches is that the first thing we're going to do is graph any reflections or stretches, and that would involve, that's the equivalent of doing multiplication before you do the other translations, which would be addition and subtraction. So we're going to follow bed mass. The fastest way to remember how to do the transformations in the correct order when you're sketching is that, is that you can't go wrong if you are going to start by sketching left to right, which just means that you do the A before the H and K. So you want to sketch as they show up, the transformations from left to right. So we start with, and here's just a little summary at the bottom of the first page, we're going to do the A value, so these two here speak to the A value, and then you've got H, and then you've got K. So that's the order that we're going to follow. Let's work an example now. So of course, if we were doing that, the one that here that would be correct is going to be the first one that we did. So this one here, not right. Actually, maybe instead of erasing it, I'll just write not correct on it so that you don't have to erase it from your notes. This one here, not correct, since the agreed upon order is going to be to follow bed mass, in that we're going to do the reflections and stretches, compressions before we do any of the left, right, up, down translations. Okay, that's what we got. Let's just jump right into the example. We're going to be doing a lot with each of these examples, so let's just read through what we're going to be tackling here. So it says, for example 1a, graph the following quadratic function using the vertex and x squared a, just meaning that we are going to make the modifications that we need to based on the transformations. B, we're going to label the vertex and then need two other points. Then we're going to write the equation of the axis of symmetry and then describe in words transformations relative to the graph of f at x equals x squared. So we're going to be using the words that we've developed over the last 2 or 3 lessons, and then we're going to write domain and range. So let's get this sketched. So let's use purple. So here we have f at x equals, I really just want the highlighter, f at x equals 2 bracket x minus 3 all squared minus 2. So what is my vertex going to be here? Well, my vertex is going to be h and k. Remember that h value is the opposite of how it appears, so that's going to be 3, 2. So let's get that onto the graph. 1, 2, 3, 1, 2. So there is our vertex. And now we're going to make the sketch. Now, this the shape of our parabola is impacted by the a value, and the a value right here is 2. So if we've got our typical 1, 4, 9 for out 1 in both directions, out 2 in both directions, and out 3 in both directions, we're going to multiply this by the a value. And again, that 1, 4, 9, it comes from the typical plot pattern from the vertex of going out, going up the same amount squared as you went out. So we're going to go out 1 from the vertex in both directions, and because the value of a is positive, up 1 squared, which is 1, times a, which is 2, and up 8, and up 18. So let's start our sketch. So from our vertex, we go out 1 and up 2, both sides, and out 2, up 8. So that's 1, 2, 3, 4, 5, 6, 7, and 8's way up here. We're not going to fit 18 on there, so we're just going to leave it. And now we're going to sketch through these. Again, we're going to try to keep it as curvy as possible, especially at the vertex. And let's get some arrows on there since this is going to continue. So there is our the sketch of our graph. We're going to label some points on here. So let's label the vertex. So the vertex right there is 3, 2. And any other couple points, we might as well just do the 2 here that are on the side. So that's going to be 3, 4, 4, 4, 4, 4, and then the last one up here, this is going to be 5, 10. Any points will do. Ideally, we would have also labeled x and y intercepts. We just don't happen to have any that fit on our graph. So those would be the priority points to label, but in this case, we don't need to because, you know, we don't have any x and y intercepts. So let's just refer back to our list. So we've done the graph, perfect. We've labeled the vertex and 2 other points, and now we're going to write the equation of the axis of symmetry. Axis of symmetry, as we know, goes down the middle of our shape, right through the vertex, all the way down. And again, I like it labeled at the bottom, but it doesn't really matter. And that will be x equals 3. So we've labeled the axis of symmetry. Now we're going to describe in words the transformations relative to the graph of f at x equals x squared. So basically, what are the transformations that were happening? So transformation number 1. Now there is no vertical reflection across the x-axis because our a value is positive. So we're just going to jump right in with a vertical. Now the 2 is larger than 1, so we're going to call that a vertical expansion by a factor of 2. By a factor of 2. Our horizontal translation, and again I'm just doing these left to right as they show up, so this is a horizontal translation. Horizontal translation, and that's going to be 3 units, as I recall, and it was to the right. The right. And last transformation, the vertical translation. So this is going to be a vertical translation. Whoops, translation. And that's going to be 2 units up, which again is as it appears at face value. So those are our transformations. The last thing I believe we're asked to do is write the domain and range. Now the domain's nice because the domain is always going to be the same for these theoretical parabolas. Set of all x such that x is an element of real numbers. No limits. We're not making any changes. The range will always have a limit on it, so the range, of course, the set of all y such that y is an element of real numbers where y. Now our actionable point is going to be the lowest or highest point of our vertex with respect to y. So it's a 2. So 2 is important, and our direction of opening is up, so it will be y greater than or equal to 2, meaning that it reaches 2 and all values greater than 2 that are positive. So there's our first example worked through. We've got a nice looking graph there. In part 2 of this video, we'll do a second example, and you can get down to the homework and doing some sketching. So see you in part 2.